Hey guys, this is Fozon, and in today's lesson, we're going to be creating superclasses and subclasses. Our lesson objectives, we're going to learn what inheritance is and how it applies to computer science. We're going to learn how to use the inheritance hierarchy in constructing superclasses and subclasses. So what is inheritance? Inheritance illustrates the relationship between objects that share certain characteristics. Inheritance allows us to create a new subclass that has the same variables and methods of a superclass, but also expands upon it with its own variables and methods. To reiterate what a superclass and subclass is, what if we create a method? What if we create a class that has certain methods and certain variables that we want to use in another class? Well, what we can do is use that as a superclass and then create a subclass that extends beyond that superclass and then has its own variables and methods that add onto the superclass. So the best way we can explain it is through an inheritance hierarchy. We've seen this inheritance hierarchy when we were using the object class. Recall that the object class is the superclass, the universal superclass of every single class. And since it's the universal superclass, every class will inherit the methods that are within the object class. And two examples of those methods were the toString method and the equals method. Our class wouldn't have a toString or equals method, but those classes would inherit it from the object class, but because they were directly extended from the object class. So they were inheriting methods from the object class. So the relationship with the object class can be, or the concept that we saw with the object class can be extended with other classes as well. So the object class doesn't have to be the only super class. It is the universal superclass. So technically speaking, if you want to look at this inheritance hierarchy, you could say person points to object, and then you could see how all classes point to object. But my point with this video is to show how we can extend upon existing classes. So see here, we have a class named person. And the thing with person is that they have rather broad details. It has a name, it has a date of birth, things like that in that nature. But there are certain things that people have that not other people have. So if you look at a student, right, a student is a person, but not all people are students. A student will have a name, will have a date of birth like a person would, but it wouldn't have, but the regular Joe or the regular person might not be a student with a GPA or with a class rank and may not even be attending college for that matter. Same thing with worker, right? Not every person is employed, but every worker or every employee is a person. So worker inherits all the values and methods of person, such as name and date of birth, because that's what a worker has. They also have a name and date of birth because they are people. But every employee also might have an employee ID, what their industry is. Not every person will have those type of values. So worker will inherit the values from person and then expand upon that. We see the same relationship with service members. Not all people are service members, but all service members are, well, people. And then subclasses can also be superclasses for other objects as well. It doesn't stop there. So we can have a college student, right? All college students are, well, students, right? But not all students are college students. They could be high school students. High school students are students, but not all students are high school students. So college student will have certain things that are exclusive to a college, but it will have the basic values and the basic methods that it will inherit from the student class, as well as the person class, since both objects or both classes extend beyond it. So student inherits values from person or methods as well. And then college student will also inherit those values, which include person and student. And we see the same thing with the high school student. It will inherit values from student, but it will also inherit values and methods from person. So what is the reasoning behind superclasses and subclasses? Well, the goal of a superclass is to find similarities between, well, your superclass, your broad class, and then the subclass that gets more specific. An example of this, again, that I used in the inheritance hierarchy is a person and student. So if we find similarities between a person and a student, then we find out that they can have a name and we have a date of birth. So we can stick that into person because, well, a person can have name and date of birth, and so can a student. But when we find characteristics specific to a student, we can't stick that into the person class. Values such as grade level and GPA, not every person has a grade level and GPA. So what we would do is that we would stick that into the subclass because the subclass has those characteristics, whereas a superclass will have the more broader values. And the thing is that we can expand person even more through other subclasses. It's not confined as subclass. The person object doesn't have to have one subclass. We can have a multiple subclasses that extend beyond person. An example of that will be worker, right? We would still have the same similarities, name and date of birth, the same similarities that you would see with every single person that exists. But then you will find characteristics that are specific to workers, such as industry, their title, or their salary or wage. Not every person has a certain title, not every person has an industry, not every person has a salary or wage. And this shows the relationship between worker and student. Workers and students have completely different characteristics that describe them. But what are the shared values between worker and student? Well, they have a name and they have a date of birth. So we could stick that into person, and then worker and student can be the children of person, or more specifically for this video, can be the subclass of the person superclass. Or, yeah, of the person superclass. Now, the name of the superclass can be kind of misleading because super kind of implies that it's really big, it's it's out there, it's magnificent. However, it's very important to note that subclasses are in fact bigger than their respective superclasses because, well, they inherit the values that they have from the superclass. So let's say if a person class has a name and an age, we will set that as the superclass, and then we have a subclass named the student class that extends beyond or inherits the values of person. Well, it will also have name and age, but it will expand upon that. So we'll have grade level and GPA. It's also important to note that the rules of public and private remain the same, even if they inherit the value. So if there are private instance variables inside the superclass, the subclass cannot directly access them using the identifier of the private instance variable. Instead, the subclass would use an accessor method to access those instance variables. So I know that I push this sort of idea that they inherit all the values and inherit the characteristics like I show in this chart over here. But it's also important to note that the rules of public and private remain the same. So what does private mean? It means that the scope remains inside the class. Well, if you declare the private instance variable within the class, then it will remain in the class. And if you're trying to access it from a different class, then you would have to use an accessor method. So when you're creating superclasses and subclasses, what you would do is you would use the extends keyword. So we have a public class superclass, and they will have its respective instance variables and methods. And then the public class subclass will extend superclass. So you would use the extends keyword after you have the public class declaration with the identifier of the subclass, and then you use the identifier of the superclass when you're extending beyond the superclass with the subclass. So let's just show it to you in motion. Let's say if we have a person object or a person class, and then we want to inherit the values of person into student, well, then we would have to use student extend person in order to imply or tell the compiler that we're extending beyond person. So we want to inherit the values from person. And it's also important to note that student will have its own constructor as well. And we're not confined to extending on just one. It doesn't have to be just a one-to-one relationship. Seen here, we see that person is extended through student, and then we could extend upon student as well with a high school student. So we're not confined to one subclass. We can subclass the superclass. Sorry, the subclass can become a superclass for another class. So let's code using a rectangle and square class to show you the relationship between inheritance and the inheritance between them. So I'm in the compiler and I have a rectangle class created. I actually have 3 classes created, so it might seem a little bit tedious or it might seem a little bit long, but just understand that some things are there simply because we need them there. But it's not that bad considering that we've already discussed most of the concepts that are seen within this video or seen within this compiler because they were covered within the object-oriented chapter. So we also have a square.java, and then we have a demo class that has a main method. So rectangle class is going to be our superclass, and the reason why we have rectangle as our superclass rather than square is because a rectangle, all squares are rectangles, but not all rectangles are squares. So with that logic, I'm going to keep rectangle as my superclass, and then I'm going to keep square as my subclass. The instance variables that we have for rectangle are going to be length, width, and area. And then we have a constructor within public rectangle that takes in 2 arguments. One is a length, one is a width, and it calculates, it assigns the instance variables of length and width to the arguments of the constructor, and then it calculates the area by multiplying the current length and the current width. We also have accessor methods for each instance variable that we have, length, width, and area, that returns the respective instance variables for each method. And then we also have mutator methods as well. So if we change the length, it's going to change the length and then update the area through an update area method that updates the area based on the current length and width values. And we have this going on with change width. And then we also have a mutator method that directly changes the area as well. Now, we also have a square class. Now, the square is the subclass of rectangle. So, to imply that square is the subclass of rectangle, what I did was that I extends rectangle. What I did was I extended it upon rectangle. And the only instance variable that I have is perimeter. Now, I understand that from your math class that you can have rectangles do have perimeters, but just for the purpose of this video, I want to show you the relationship between superclasses and subclasses and what to be accounted for, especially when we're trying to manipulate values and then access certain methods. What can we access and how can we access those values? So perimeter in real life again can also be used with a rectangle, but I want to use this exclusively with the square class. So rectangle doesn't have a primitive instance variable, but it does have an area, length, and width instance variable. We also have a separate constructor for the square class, and it will take in only 1 argument. And you don't need to know the syntax of the super keyword just yet, but just know that it creates or it accesses the constructor of the rectangle object and then sets the length and width respectively in order to, assign values to the length and width, since the values of, since square extends beyond rectangle, it accesses those methods as well. And as you can see, the constructor is a public constructor. So this simply just accesses the constructor, and I'm sure that you can make the assumption of how it works. And I also have a perimeter assignment, and this simply multiplies the length by 4 in order to get the perimeter of the square, because that's how you calculate the length of the perimeter. I have an accessor method. Sorry if I stumbled there. We have public integer get perimeter. This is just simply going to return the perimeter because there is no perimeter within rectangle, and since there is no perimeter within rectangle, there is no accessor method for perimeter. So we need to create that within the square class as well. And then I have this special type of method. It's called the mutated method, and this is really what I want you to get out of this video, because it's very interesting, the relationship of public private within the superclasses and subclasses. So I know that it's implied that square inherits the values of rectangle. It's implied that square inherits the values of rectangle. So technically speaking, these instance variables can reflect the values of a square. However, it cannot directly access those values. So if I wanted to change the length, I could not do this dot length is equal to whatever the value that I have here. This is a bit iffy. Is equal to length. This does not work because, not this dot length, this dot length. We cannot do this because, well, we can do this within this class because the length value, the private length value is within this class. So we can use this when we're using the mutator method of within this class. However, within the square class, it cannot access the private instance variables of the rectangle class. So this doesn't work. Let me reiterate, this doesn't work because the private instance variables of rectangle are private, even though we can use the private instance variables to describe square. So what we have to do to make this work is that we have to access a mutator method within rectangle. So we access a mutator method since it inherits the public methods. So it can access the public methods because what does public imply? Because public implies that we can access what can be accessed by other classes outside of the class that we're currently in, or other methods that are outside of the class that we're currently in, whereas private indicates that we can only use it within this class. So in this case, we would have to use the mutator method change length in order to change the length when we're asked to update the square length with a new length for the rectangle, or rather more specifically the square. So let me do change length and then update that with the argument's length. And then it will simply access the update perimeter value. And as you could see, for me to update the perimeter, I could do actually a variety of two things. What I could have done, technically speaking, was I didn't even have to use get length. I could have used int length and then put that argument there and then use that as my arguments for length. However, I wanted to show you again the relationship between the private and public values. Again, perimeter is within this class, so we can access that class through just a simple call, this.perimeter, or even just perimeter, because we don't need the this keyword. But when we want to access the length in order to actually do the calculation for perimeter, 4 times the length, we cannot access it directly through the value. We cannot do 4 times length because it cannot find that. It will give us an error. It's even telling us to change the visibility to well protected or even public. What we need to do is use a accessor method such as get length, and this will return the length private instance variable, since the get length method is a public method that can be accessed by other methods outside of the square class. So let me save that. And then I have this demo class. What it does is that it simply creates a square. It creates memory for a square and then ultimately creates a square with 5 as my length size, as my length and width size. And then I ask it to print out the length, the width, the area, the perimeter. Then I want to update the square length. So it's going to access this method. It's going to access the mutator methods of the rectangle class, since we cannot access the private instance variables directly. And then we're going to reprint the values to see whether or not it makes the respective changes to both our rectangle and square private instance variables. So let's see if this works. And as you can see, it works. So we have a length of 5, we have a width of 5, and And the reason why this is able to work is because we have these values, we have these get length and get width methods within the rectangle class. We don't have a get length get width method within our square class, so it inherits that through the extends rectangle. Since it's a subclass, it inherits those methods. So those methods, these methods, public methods, are considered to be a part of square. So we can access the get length method. We can access the get width method. We can also access the get area method, another method that is not within the square class, but it's within the rectangle class. So square inherits that from the rectangle class. And then what it does is that I want to get the perimeter, so it accesses the get perimeter method within the square class, a method that is not within the rectangle class. And then when I tell it to update the square length to change the length to 3, then it makes the respective change. So rather than me changing the private instance variables directly, since I cannot do that because, well, they're private, I have to use the mutator methods that are public, the public mutator methods, change length, change width, and, well, it changes the length, it changes the width. It updated the area when we access the get area method of the rectangle class, and, well, we changed the perimeter as well. 3 times 4 is 12. So as you can see, inheritance can be a little bit tedious, but it expands upon your object-oriented programming concepts, and it's very applicable to a variety of programs that you will develop in the future if you're pursuing computer science.